Okay, Mr. Allen here, going to go over an example of graphing sketching so you kind of get the idea of going through all the steps in order to put together the best possible graph you can make. So in this case I have a binomial divided by a binomial, and my first instinct when I see any kind of binomial will always be to factor. Sometimes this form of the equation will actually be easier to work with, other times this will, so I'll kind of keep both available to me. So first thing, kind of going through the various steps we listed on our curve sketching algorithm. First thing says determine any vertical asymptotes, and then determine what happens around those asymptotes. So basically deal with the vertical asymptotes first. Vertical asymptotes from the factored form, x equals 4 right here, and x equals 2. So again, those are the numbers that when plugged into the equation give me division by 0. Now what happens with those? In order to figure out kind of what's going to go on the left and the right of the vertical asymptote, I need to test values that are very close to those. I usually go 2 decimal places. So the y value when x is 1.99, again probably working from the factored form of the equation is best here. If I put 1.99 into this first bracket, I get 1.99 plus 8, that's a positive value. 1.99 plus 2 is also positive. 1.99 minus 4 is negative. I'm going to get another negative, so I get positive, positive, negative, negative. And if I multiply and divide 2 positives and 2 negatives, I get a result that is positive. And that's, maybe can't see very well, but there's a purple arrow right up here that I just drew in that section, literally just kind of right there, saying that's where my graph is going to continue up. I don't necessarily know what's going to happen leading up to that point, but at that moment it's going to be going up the side of the vertical asymptote. Similarly, I can work out the various other options here. When x is 2.01, again plugging in those values, 2.01 positive, positive, negative, positive, so overall negative. 3.99 positive, positive, negative, positive, overall negative. 4.01 positive, 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 overall positive. And so this section of the graph I can see hopefully and get far enough down. I've got my little arrows going up here in purple, and then down here and down here in purple. Again, they don't necessarily show up the best, but that's what I've got at those 2 points. Continuing on then, on my algorithm, the third step says determine any intercepts that you can. The intercepts in this case are fairly easy. I can make x equal to 0 and solve, in this case probably in this version of the equation is a bit easier. 0, 0, 0, 0, I get 16 eightieths, which is 1/5. And so my y-intercept is kind of right there. When y is 0, I can solve, so essentially the numerator would have to be 0 for this entire expression to be 0, or for y to be 0, which means I have zeros at -8 and at -2. And so there they are, there and there. Take that arrow out of there. Part 4 says find the derivative. Well, find the critical numbers by determining when the derivative is equal to 0. This is my derivative. The solution for that is over here. It's fairly lengthy, so I just put it on the second page. Similarly, the second derivative is on the second page as well, so you can check those if and when you want to. And let me get rid of that. Number 5 says once I've found my derivative, to make it equal to 0. Again, logic by itself tells me, or if I start trying to solve this, when I multiply, if I set this to 0 and multiply this through by this value, I end up realizing that the only way I'm going to get a 0 here is if x squared plus x plus 11, if the factors in the numerator that contain x values equal 0. So that's the only thing that can make this whole expression go to 0. And I used the quadratic formula to solve and found that x is negative 3.854 or 2.854. The y values that go with that are there and there. Basically just plugging the x's we have back into the very original equation, this one or this one again, whichever seems easier. So I have these 2 points, and they will be on my graph. So one is right there, the other is right there. But before I got to this point that you're looking at right now, I needed to determine whether those values were maximums or minimums. And again, oh, look at that, I made a mistake. These are, because I am trying to determine what the slope is in each of these cases, I need to be looking at the slope. So it's the slopes around the 0 that I'm interested in. So the slope at -4 is negative. The slope at -3.5 is positive, which means that my graph decreased down to this 0 and then increased afterwards. Tells me that that point right there is a minimum. Likewise, if f prime is positive at 2.5 and f prime is negative at 3, it means I must have been increasing and then started to decrease after I hit that point. And so this is a maximum, this is a minimum. I jotted those in just so I would remember because I was still a ways from getting to the point where I was done at that point. Continuing with the algorithm, number 6 says determine horizontal or obliques and then figure out how we're approaching those values from above or below. And so the horizontal asymptote is quite straightforward. Looking at, again, the very original equation, the only thing that matters in determining a horizontal asymptote is the degree of the numerator and the degree of the denominator, so the highest power in both the numerator and denominator. So this section, I can't do it. So these two values right here basically are the ones that matter to me. And so if I look at that, I get some large number divided by 10 times that same large number, which is 1/10. So my horizontal asymptote is at y equals 1/10 or 0.1. Now realistically, option 7 here, or step 7, which is determining whether I'm approaching from below or above, is kind of irrelevant because usually, certainly with a horizontal asymptote, it should be pretty clear what's going on. And once I do the final step and determine inflection points and so on, it really is pretty obvious. Nonetheless, we should know how to do it. And so the question is really, when I get way out to the left or way out to the right, when my x values get to be -100, -1,000, -10,000, 100, 10,000, 100,000, things like that, are the y values out there going to be slightly above or slightly below the horizontal asymptote? I tested -100 and found that the number was just below 1/10. I tested the number +100 and found that it was just above 1/10. And so that gives me these red arrows, which suggest that I should be approaching from above here and just below here. Kind of finishing up now. Second derivative, again, second derivative, the calculations are on the second page. It was not very nice, but certainly doable. When I set the second derivative to 0, in this case, this bracket here has to be 0, and it cannot be factored. So my only option was to use technology. And so that's why I've got Desmos written in here. I literally went on the graph and I sketched this to find where the 0 was, and it was at negatives, sorry, I graphed this on Desmos, and I found that x equals -7.24 was where the 0 occurred. I then went back to my original graph and found that this was the y value at that point, and so I plotted this point as best I could right in here. And then just to verify, I checked for concavity. What was the second derivative at -8 and at -7? It was negative at -8. It was positive at -7, which means that the curve was concave down at -8, concave up at -7. And so you can sort of see that this section of the graph is all concave up until I get to this point right here, at which point it flips around and becomes concave down moving forward. The final step was to fill in the rest of the graph. There was no further information in here, just penciled it in, and the blue up here allowed me to finish up, join up with my purple. The blue here allowed me to join my two arrows, and that was the end. So hopefully from that you can kind of follow along as you need to. If there are specific questions about any specific parts, certainly feel free to ask. It is too much to do online on the tablet all at once, and so we do need to start focusing our questions moving forward.